All right, so let's look at the first set of numbers. I think integers are next. Yeah. I ran out of room. Okay, the first three sets of numbers, we have our natural numbers. That's positive 1 on to infinity. No decimals, no fractions. Whole numbers, difference between natural numbers and whole numbers is the fact that we have 0 involved in our whole numbers. You can think about whole for the 0. So that would be 0, 1, 2, 3, 4, on to positive infinity. Once again, no decimals, no fractions. And then your integers, all of your negative numbers to your positive numbers. So it's negative infinity to positive infinity. Once again, no decimals, no fractions. All right, so those are your first three. All right, let's see, rational, yeah. Oh, also I didn't mention, um, for some of you, you have your cameras off, and that's fine. You don't have to have your cameras on. Now, if we do proctor tests, where I have to see and watch it, then of course on those days you would enable um, your cameras. Some tests will be proctored. Some I will let you just take it, at your leisure. But if I do proctor tests, then I will need to see your cameras enabled. Now, during the lecture, since I can't see most of you, if I go too fast or I scroll up too fast, you got to let me know because I can't see if you're writing. You know what I mean? So communication will be key to making this thing, happen, in a positive way. So just let me know and I'll just scroll back down or I wait, or if you need me to re-explain or anything like that, just let me know. Um, yeah, let's go like this, any number. And I didn't mention this, but don't forget when you look at your integers, all whole numbers and all natural numbers are integers. So that is included in that. And then when we look at our rational numbers is any number that can be written as A over B, where A and B are integers. So that means 3 over 5 would be a rational number, negative 7 over 9 would be a rational number. 8 over 1 is also a rational number, but don't forget, if you simplify 8 over 1, that's the same thing as 8. So that means all integers are rational. And remember, if all integers are rational, that means all natural and whole numbers are rational as well. All right. Also, let's see. Any decimal that is terminal or repeating is also rational. So examples of that. 0.75 is considered rational. That's a terminal. That's considered terminal decimal because it ends. And that is 3/4. So that's why, you can rewrite that as 3/4. Let's see, 0.2. Let's go 0.3 repeated. That's the same thing as 1/3. So if a decimal is terminal, in other words, it has an end, or it repeats, on to infinity, then that is they will be rational as well. They will be considered rational as well. All right, questions before we go to irrational numbers? Yeah. So irrational numbers would just pretty much be anything that's not rational. So if you cannot write it as a over b, with a over b being a and b being integers. So examples of that: square root of 2. You can't take the square root of 2 evenly, and we'll talk more about square roots in a second. Pi, that's the decimal 3.141592, blah 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 blah. Negative pi over 3, so variations of that. Square root of 5 over 7. If you have something that's not an integer in your decimal or your numerator, I say your decimal, your denominator or your numerator, they would be considered irrational. And then the last category, real numbers. All the numbers that we've discussed are real numbers, all your rational or irrational. Let me go here. So your generic number line has 0 in the middle. Everything to the right of 0 is positive. Everything to the left of it is negative. If you're comparing numbers, the number that's furthest to the right will always be the greatest value. And we will do comparison with our, there you go, inequality symbols. I think that's the only ones we're using in this section. Okay. Also have less than or equal to. So those are a few inequality symbols. I said few, are 4 inequality symbols: less than, greater than, less than or equal to, greater than or equal to. Same as your first 2 symbols, but you have a bar under them to signify or equal to. Let's do it like this. All right, so let's use those symbols. One of the exercises that I see here, one of the first exercises I see, you have use less than, greater than, or equal to make a true statement. Okay, let's do this. So just want to make sure you guys are okay with how we use the symbol. First of all, you want to establish, of course, I know this is the fact that you recognize what number is greater. I know that's elementary, but making sure we understand which symbols to use sometimes can be problematic. And the way I always remember, because I remember what my teacher told me back in the day, is that the mouth is always trying to eat the bigger one. So the mouth is going to be open towards the bigger one, and that's how you would write it. And I remember they put the teeth up here. I remember one teacher told me it was an alligator. Another teacher told me it was a shark. So the mouth is always going to be open to the greater number. The mouth of your symbol will always be open to the greater number. So whether you remember the words or not, that doesn't matter if you hold true to that. So this reads 2 is less than 7. Same thing as if I had 130. We know 100 is the greater number, so the mouth is going to be open to the greater number. So that reads 100 is greater than 30. All right. Same things if I had negative numbers involved. Let's say if I had a negative 35 and negative 4. If you ever get confused about negative numbers and what is greater and what's not, always think about your money. Would you rather be negative $35 or negative $4? Of course, we would rather not be negative at all, but you would rather choose the negative 4. You know, you're talking about going further in debt. And then if you were to look at the number line, remember I told you the number that's furthest to the right will always be the greater number. Negative 35 would be over here, and negative 4 would be closer to 0. So the negative 4 is what would be greater, you know, when you talk about your negative numbers and comparing your negative numbers. Questions on that? Any questions? Any questions? All right. Let's do this first before we go absolute value. I'm about to take one of these out. I'm moving that 112. Let's go with negative 311. Okay, so they give us negative 2, 0, 1/4, negative 1.5, negative 3, 11, square root of 2, and square root of 81. And we want to list each one of the numbers that fit into the sets that we discussed initially. So we're talking about first our natural numbers. So we want to say, remember where our natural numbers start. Natural numbers start with +1. It goes from +1 to infinity. So anything negative will not be a natural number. And remember, no decimals nor fractions are natural numbers. And 0 is not a natural number. So we're looking here, we see +11. And then also, right, square root of 2, we can't take the square root of 2 evenly. When you're talking about the square root of a number, you want to know, is there a number that you multiply to it twice that will give you the number that's under the radical? So in other words, if I have the square root of 25, the answer is 5, because 5 times 5 is 25. Square root of 16 is going to be 4, because 4 times 4 is 16. So I cannot take the square root of 2, because there's not a number that when you multiply to it twice will give me 2. But I do have the square root of 81, which is 9. So actually the square root of 81 would be a natural number. All right. And if you have one like this in my math lab, make sure you put in the answer the way that they give it to you. So notice I didn't put 9 down here beside the 11. I put the square root of 81. So you want to put in the answer the way that they give it to you, even if it can be simplified.
I got a question.
Mm-hmm.
You know how you gave us the example of the square root of 2? How come you couldn't use the square root of 2 for a natural number?
Because you can't take the square root of 2 evenly. Like if you were to throw the square root of 2 in the calculator, it'd give you a run-on decimal, like I think it's like 1.44 on repeating. Because there's not an integer when you multiply it to itself twice that will give you 2. So like when I look at 81, 9 times 9 gives me 81. That's a solid number. That's a natural number. Same thing as if I had the square root of 49. If I had the square root of 49, that's 7. So 7 is a natural number. But the square root of 5 is a decimal. So I couldn't use that as a natural number. Square root of 11 is a decimal. Can't use that as a natural number. Square root of 121 is 11. So I could use this. You see what I mean? Like you have to be able to take the square root of that number that's under the radical evenly in order for you to be able to use it as a natural number or a whole number.
Okay, I understand. So you can't get nothing else out of 2.
Right.
Okay.
All right. All right, so whole numbers, remember the difference between whole numbers and natural numbers is just the 0. So we have a 0 up there, so we use 0, 11, square root of 81. All right, integers. Remember, integers involve negative numbers. No decimals, no fractions though. So we would do the -2, -3, and we would use all of our whole numbers, 0, 11, square root of 81. All right. D, we're looking at rational numbers. So your rational number is going to be all of these integers. So remember, you can cut back on how much you have to think about this. As you go throughout, 11, all your natural numbers are whole numbers. All of your whole numbers are natural numbers. Are integers, excuse me. All of your integers are rational numbers. So you already know these are rational numbers. So now you need to look at your list and say, are there anything else? Or is there anything else that needs to be added to that list? So we're looking at 1/4. Remember, rational numbers involve fractions and decimals. -1.5. And that's it. So then we'll go ahead and use all of your integers. So you got that 1/4, negative 1.5. And that's it. Remember, fractions and terminal decimals, or if you had a repeated decimal, you know, that something that repeats on to infinity, those would be rational numbers as well. Why did that come back? All right. Irrational. So irrational is going to be all of the other numbers. So you can look at this list that we have for rational numbers and then see what else is not there. So we know that square root of 2. I think that's it for this list. Yep. Only thing that's irrational is the square root of 2. All right, and then the last one, your real numbers, is just going to be the whole set. The whole, all of those numbers are real. So we don't have any imaginary numbers. Yeah, imaginary numbers are a thing, even though I just said they were imaginary. But in math, there are something that are numbers that are called imaginary numbers, and as you guys get closer and closer to calculus, some of you guys are destined to meet calculus, right? You will be doing imaginary numbers then. But yeah, not now. And I don't believe in this class at all. So every number you come across should be real. All right, one last thing in this section. Any questions up to this point?
I'm not on the math lab right now. So what section is this? I'm only taking notes.
1.2.
Okay.
All right, last thing in this section, we're looking at absolute value sign. It's a counting tool. Probably should have stayed purple. It's all right. Let me do it. No, the result. All right, so the absolute value is a counting tool, and it represents how many units a number is from 0. And so the result will always be positive. It's not the opposite, it's positive. A lot of times people want to say it's the opposite, but be careful, it's going to be positive. So when you look at the absolute value of 3, that's what those 2 lines mean, 2 long lines on the outside of 3, the absolute value of 3. You're asking yourself, how many units is 3 away from 0? So if I look at the number line, and I know you don't have to do this every single time, I'm just showing you where it's coming from and what we're talking about when we say units. So how far is 3 away from 0? Is 3. Same thing with -3. How far is -3 away from 0? It's 3 units. And that's all the absolute value is. When you apply the absolute value to a number, the result will be positive. So if I'm looking at the absolute value of 0.25, the absolute value of 0.25 is 0.25. The absolute value of -7/8 is going to be 7/8. All right. Now, if you have a negative sitting outside of the absolute value of a negative, well, let me do it like this. Before I go there, I think we're doing opposites. If not, we'll see it in a second. So I'll just go over it now. Before I do that, questions on what I said about absolute value. When you apply the absolute value, you always get a negative result. I mean, I always get a positive result. All right. So now, when you talk about opposites, your sign can only be positive or negative. I mean, that's just it. There are only two signs. So when we talk about the opposite of positive, we talk about negative. Talking about the opposite of negative, then we're referring to positive. So if I have 5, the opposite of 5 is -5. If I have -10, the opposite of -10 is +10. So they are opposites. If I apply the negative to -7, negative to a negative will turn positive. Let's see if I have enough room. Don't have enough room. So negative to a negative will turn your number positive, just like if you had, if you want to do the application of negative to a +18, then that will be -18. So the negative sign just invokes the opposite of whatever number you're dealing with. And so the reason why I went there is that if I have, this is just another example, if I have negative absolute value of -21, now these two scenarios are different and you have to be careful. I just showed you that negative to a negative, when you have parentheses, will turn into a +21. But we just finished saying that when I have the absolute value of -21, the result is +21. So, but this negative on the outside of the absolute value is still there. So your result is going to be -21. So that negative was not affected by the absolute value because it wasn't in the absolute value sign. So everybody clear with that? Everybody okay? Let's make sure, because a lot of times they'll trip people up looking at these symbols.
That's why I always get mixed up at. So what's the difference in the absolute value and the parentheses?
The absolute value, great question. The absolute value is an actual application. When you use absolute value, you're actually applying a concept in which I'm getting feedback. Can you mute real quick? Yeah, thanks. Appreciate that. Appreciate it. So absolute value is an actual application. It's a concept. When you use absolute value sign, there's an absolute value concept that comes along with it. So those two lines, these two lines right here, say that when I have a number in that absolute value sign, the result would be positive. So that's what happened here. I had a +21. Now there was a negative that sat on the outside of those absolute value signs that was never affected because they weren't on the inside. And so that's what this negative did. It just sat there. And so my result was -21. My final result was -21. Now the absolute, not the absolute value, now parentheses, they don't have an application at all. They're just there just for grouping symbols or just for notation. So here, this negative and this negative can be affected by each other, wherein these negatives cannot, because the first thing you have to do is apply the absolute value before you do anything else. So that absolute value actually is an application, wherein once again, these parentheses, they're just notation. They just hold that number there. All right. Questions on anything I've said? All right, so let's do a few out of 1.3. Okay, so 1.3 exponents, order of operations, variables, and equations. I did not see any equations in here. What kind of equation are you talking about? 4 times. Oh, they're just writing them. They're not. Oh, they're not solving. Okay, I didn't think I saw solving in here. Okay. So first thing we're looking at are exponents. Let's see if I have 2/3. All right, so if we have 2 to the third power, that's different than having 3 to the second power. So the number that is regular size is your base. The number that's superscript up to your right is the actual exponent. So this is not 2 times 3. And we have to be careful here because that is familiar to us. 2 times 3, which will give us 6. A lot of people make that mistake because they get in their flow. And, when you get in your flow, sometimes the numbers start to come together and everything. But this is 2 times itself 3 times. So the exponent just tells you how many times you're going to multiply the base to itself. So just like down here, this is 3 times itself twice. All right. 2 times 2 times 2 is 8. 3 times 3 is 9. So you get 2 totally different numbers. But that's how exponents work. Take your base and multiply it times itself that many times that the exponent suggests. 7 to the first power is going to be itself. It's just 7. So anything to the first power will be itself. And so it's also understood that if you see a number that does not have an exponent, it's a 1 there. So that's understood, that relationship, and that will come into play later on, that you know that there's a 1 there for the exponent. If I have 3 to the 5th power squared, yeah, that's good enough. That means we're going to do 3 to the 5th power. Not 3 to the 5th. I said 3 to the 5th power squared. Sorry, 3 over 5 squared. That's 3 over 5 squared, or 3/5 squared. So that's 3/5 times 3/5. And all you would do is multiply across. That'll be 9 over 25. Questions on exponents? All right, so let's look at order of operations. So make sure we hold true to this, and we got to be careful because there's one thing that's not emphasized a lot, and I see a lot of people getting this wrong on Facebook and social media, and I get pulled into a lot of arguments because people know that I'm a math teacher. So there's this one element that a lot of people mess up on. So let's take a look at it. So PEMDAS, please excuse my dear Aunt Sally or Shantae or Shaniqua, depends on the name of your auntie. All right. So P is going to represent, normally back in the day where they introduced PEMDAS, in elementary, they said P for parentheses. We are going to use P for parentheses, but really it represents all grouping symbols. So you're talking about parentheses, brackets, and braces. I can write braces better than that. I'll write all of them better than that. Parentheses, brackets, and braces. So the first thing that should get your attention when you're doing order of operations will be any grouping symbols that you see. Like I said, P stands for parentheses, but we're also going to include grouping we're also going to use brackets and braces as a part of that. Next thing that should get your attention, exponents. So we're talking about tiers of operation. Your first tier, grouping symbols. Second tier is your exponents. Now here's where a lot of people make a mistake. multiplication, and division, they are on the same level. Why is this not moving to the side? There we go. So they're on the same level, and you do them from left to right. And I'll show you what I mean in a second. Same thing with addition and subtraction. So there are only 4 tiers of operations. And even though multiplication comes first or comes before division in the order of PEMDAS, it does not take precedent over division. You would actually do it from left to right. So there are 4 levels of operations or 4 tiers of operations. So let's say if I have 18 divided by, all right. Yep, so let's do it like this. 18 divided by 9 times 2. So now if we go in the order of PEMDAS, in other words, we just say multiplication comes before division. So that means we would do 9 times 2 first. So I'm going to do it the wrong way, then do it the right way. 18 divided by 18, and then go ahead and do your division, and that will be 1. And so I did that just to make sure we understand that just because you get a solid number does not mean you have the correct answer. All right. So what we're supposed to do is, like I said, when we look at multiplication and division, we do them from left to right. In our problem, we would do the division first. 18 divided by 9, which is 2. Then 2 times 2 is 4. And that will be your correct answer. All right. Everybody okay with that before we look at a problem? All right, so let's look at one. All right, we'll do these. So we have 6 divided by 3 plus 5 squared. That's 5 to the second power. So if we go completely or strictly by PEMDAS, the first thing we should do is our exponents. So the 6 divided by 3 plus, and when we talk about 5 squared, that's 5 times 5. That's going to be 25. Then 6 divided by 3 is 2. And 2 plus 25 is 27. So when you look at these problems, that's why it will be important for you guys to send me your scratch work. Because, you know, if you can use it, just throw this in the calculator, and I'm pretty much just shooting the breeze right now. You know what I mean? If all you can do is throw it in the calculator. So we do want to emphasize the process. So make sure that, you know, when you do use your calculator, maybe to check that you're still doing the scratch work and showing your steps. All right. Here, we got division and multiplication. So we just finished talking about this scenario. We'll do the division first. 20 divided by 5 is 4. Then 4 times 4 is 16. . So we have 2 times the quantity of 12 plus 3 over the absolute value of negative 15. So what we can do here is simplify as much as we can up top first, then look at simplifying what's on bottom. In other words, treat them like they're 2 separate problems, then bring them together. So when I look at 2 times the quantity of 12 plus 3, remember parentheses is supposed to get our attention first. So we would do the 12 plus 3. So that'd be 2 times 15. And I'm going to just leave this absolute value of negative 15 down bottom for right now. And then 2 times 15 is 30. So we simplify the numerator as much as possible. Now looking at our denominator, absolute value of negative 15 is positive 15. So that's what we just finished talking about with the absolute value. And then to finish it off, 30 divided by 15 is 2. So make sure you take note of the different ways that you can represent multiplication, different ways you can represent division. When it comes to multiplication, notice before we use the dot, when we're up here, when we look at division, we use our symbol here for division. Here we use the dot for multiplication. So now here is assumed that then when something is right up against the parentheses, that's multiplication as well. So they didn't have to put a dot there, but they assume when a number is right up against parentheses, that is multiplication. And then here, that's division. So just multiple ways they can represent division and multiplication. So make sure you're watching that and not thrown off by your symbols. Is that a hand up?
Yeah,
Yep.
I was just gonna ask. So basically, anytime that we're dealing with like the negative, just use our absolute value to turn it to positive if the top number is positive.
No, that was given in the problem. So if this was like this, I would have never done it. So the initial problem gave us the absolute value of negative 15. So now if that was never there, let's say if it looked like this and it had negative 15 down there, then ultimately we would have had 30 over negative 15. And then positive 30 over negative 15 is negative 2. So our answer would have been negative because the negative would still been there from the beginning.
Scroll back up a little bit.
Is that what you were asking when you said about the absolute value?
Yeah, like what the difference is.
Yeah, because like I said, you don't just implement absolute value. If they didn't give it to you in the problem, you can't just put it in there. So the only reason we used it or applied it is because it was given initially. And then, so the absolute value of negative 15 is positive 15. So yeah, I think that hopefully that answered your question.
I think so.
Okay, all right. Saw somebody in the chat trying to run the Zoom. Okay, all right, fine, that's fine. All right, and okay, let's go to this next. Well, I guess I'll leave that like that. Let's do some fractions. I know somebody wanted to do a fraction. And I hear somebody say they want to do a fraction. All right. So here we have 3 over 2 times 1 over 2 minus 1 over 4. I mean, I said 1 over 4, 1 over 2. Now we have to be careful here. We have to remember our fractional rules, fractional concepts. If you need help with fractions, forgot how to deal with your fractions, make sure you get with me. Make sure you email me. If you want to check out videos of me explaining fractions, I can do that. Or if you want to sit in an individual Zoom session to talk about fractions, we can do that. But this section or this, I'm looking at chapter 1. I don't believe it sits down and goes to the foundational steps on fractions. So if you need fractional help, make sure you get with me. So we're going to do the multiplication first. Just want to emphasize All right, so you do not need common denominators to multiply or divide fractions. Okay, just want to emphasize that first. So when I look at 3 over 2 times 1 over 2, you just multiply across, and that's going to be 3 over 4. All right, so now we have 3/4 minus 1 over 2, or 1/2. You must have common denominators to add and subtract fractions. You do not need them for multiplying or dividing fractions, but you have to have them for adding and subtracting. All right, somebody needed me to scroll back up. Don't know how far you want me to go. Is it right here? I don't know. Nobody's saying anything. I know you did that in chat. Just let me know. So once again, you do not need common denominators to multiply or divide fractions, but you do need them. You must have them in order to add and subtract fractions.
Can you just go up to the original problem real quick? I just wasn't able to copy it down.
Not a problem.
Thank you.
So the first thing we did was multiply 3/2 and 1/2. 3 times 1 is just 3. 2 times 2 is 4. So that's how we got 3/4. So now we need to subtract 3/4 and 1/2. So we need a common denominator. Least common denominator is going to be 4. And this is going to be so it's the smallest number that each denominator can divide into evenly. So you see that 4 and 2 can divide into 4. So it's not about what can divide into them, it's about what they can divide into. What's the smallest number that both of them can divide into evenly. All right, so I want to turn my denominators into that 4. 3/4 is fine, but the 1 over 2, I need to be able to turn that 2 into a 4. You ask yourself what times 2 will give you 4. That is 2, but whatever you do to the bottom, you got to do to the top. And so that'll be 3/4 minus 2/4. Now that you have common denominators, you can go ahead and subtract, and that will be 1/4 as your final answer. All right. Let's look at this one. All right, so this next one, we have 3 times the quantity of 4 plus 2 times the quantity of 10 minus 1. All right, so you always, if you have multiple grouping symbols, you always want to go to your innermost grouping symbol first. So that 10 minus 1 should get your attention first. Everything else should stay the same. The 3, the 4, the 2, 10 minus 1 is 9. All right, then check inside your grouping symbol. If everything's simplified, you can move on, but if everything is not simplified, you need to keep going inside of there, and you will see that we still have work to do on the inside of our grouping symbol. We have 4 plus 2 times 9. So the next thing that will get our attention is the 2 times 9, which is 18. All right, still inside of our grouping symbol, 4 plus 18 is 22. And then that 3, remember I said whenever it's right up against a parentheses or a grouping symbol, you do that multiplication. So 3 times 22 would be 66. All right. So try those out. Of course, if you get stuck on any of them or anything, always feel free to shoot me one, and I'll try to walk you through it. You know, whether you take a picture of it or I didn't see Ask My Instructor. I'm gonna check that out. There should have been a help tool in my math lab that's, says Ask My Instructor, where you can shoot an email to me through through my math lab, but I'll check that out. Next thing to introduce in this section are your variables. Tell us to evaluate if x is equal to 3 and y is equal to 2. All right, so if x is equal to 3 and y is equal to 2, we're going to plug in those values for x and y, and then perform the order of operations. So here we have 2x minus y. So that's 2 times 3 minus 2. Just plugging in accordingly. 2 times 3 is 6 minus 2. And that'll be 4. Next one, x squared minus y squared. Once again, x is 3. So that's 3 squared, y is 2. 3 squared minus 2 squared. 3 squared is 9. That's 3 times 3. 2 squared is 4. That's 2 times 2. And then 9 minus 4 is 5. We're almost finished. Got one or two more things to mention, and then we'll be done. But questions? Any questions? All right. Let's see. All right, I'll write this just in case. All right, so one of the last things that we'll be talking about, equations. Equation is a statement that two algebraic expressions are equal. So a simple example of that is x plus 5 is equal to 8. Then a solution, value or values, depending on the complexity of your equation, you could have more than one solution. But it's value or values that will make an equation true. So an example of that is x equal to 3. So if I were to take that 3 and plug it in here, we see that 3 plus 5 is equal to 8. So you want to know when is x plus 5 equal to 8? That's when x is equal to 3. All right. So you could see this as an exercise. Decide whether 2 is a solution of 3x plus 10 equal to 8x. So if you want to know if that is the case, then you will plug it in for x. If it ends up being a true statement, in other words, equal on both sides, then it is a solution. If not, then it's not a solution. So that's 3 times 2 plus 10 equal to 8 times 2. On the left side, 3 times 2 is 6 plus 10. On the right side, 8 times 2, 16. Then on that left, 6 plus 10 is 16. Notice we have 16 equal to 16. And the answer is yes, yes, it is a solution. All right, last thing, and then we'll call it a day. Well, shoot, call it a week, right? So we'll call it a week. All right, so um, all right, so next thing is translating phrases to algebraic expressions. We have keywords. On page 23. So if you want to reference those keywords that we're about to use, that's on page 23 of your text. And so you're going to have keywords that's going to help you write a mathematical expression or a mathematical equation. So say write. All right, so the first one, write the sum of a number and 3. And they also said in the directions, use the variable x. So, when you see your directions, you'll see all this stuff. But write the sum of a number and 3. Sum means addition. And like I said, when you look at that page 23, you'll see your keywords. So all you would do is write x plus 3. Or you could write 3 plus x. We'll learn later when we look at our properties that addition is commutative, so you can write it. 2 plus 3 is 5. 3 plus 2 is still 5. So it doesn't matter which way you use it or write it. Let's see. Nope, let's go here. Twice a number. That's 2x. Or you could do 2 dot x for that multiplication symbol. Let's do at least one more. Yeah, let's do that. All right, 5 times the number increased by 7. So 5 times the number is 5x, increased by 7 plus 7. All right. Questions? Any questions? All right, this is the last one, but I wanted to make sure we saw the difference in this versus the last one, the last problem that we did. Here it says write, I'll use purple, write an algebraic expression. Here it says write each, and it just said equation, but the key phrase here is equation or key word. So if you're gonna write an equation, you have to have an equal sign involved. So if you just say an algebraic expression, there is no equal sign. An equation has an equal sign. So you have to look for that when you're trying to do or trying to hold true to your directions. So yeah, you're still going to be using those keywords, but now you have an equal sign that you need to implement somewhere in your final answer. The quotient of 15 and a number is 4. So we want to write an equation. The quotient of 15 and the number is 4. Well, quotient is division. So the quotient of 15 and a number. So you would write that as 15 divided by x. Or you could use that other divisional symbol. Remember, you could have wrote this, but I chose to write it as a fraction. So it's up to you. Now, is your equals. See if they used anything else other than, nope. So, yep. So there are other ways of doing it, but they only gave you is, so that's all you have to worry about. Is your equal sign. So is 4. That'll be your answer. We're just emphasizing the directions. They'll say algebraic expression, there's no equal sign, but when they say equation, an equal sign needs to be used. Oh, what about this one? Four times a number. All right. All right, last one for tonight. 4 times a number added to 17 is not equal to 21. So 4 times the number is 4x. Added to 17 is plus 17 is not equal to, use your equal sign and put a slash over it, and then it's 21. All right. Questions? Any questions before we look to close out for today? So So we got 2 sections in, which was good. I always shoot high, so I told y'all 4. I know yeah, some of y'all might be happy we didn't touch that 4, but it's all good. So you have 2 sections that we've discussed. Take a look at them. You got a week to knock them out and see if you have any questions, or at least make attempts on them. See if you have any questions on them. Next class we'll pick up right here with that was 1, 2, 1, 3. So we'll pick up at 1, 4 and go from there. All right. Any questions, concerns, comments before we close? I see a hand up.
Yeah, so I'm looking at this, and I know, like, we're working on like tentative dates and stuff right now. So when I look in Math Lab, I see 1.3, 1.4, and 1.5. What out of those sections do you want completed to constitute as our homework?
You can just keep up with the lectures. Today we did 1, 2, and 1, 3. You can just do 1, 2, and 1, 3 and still be and be current.
I'm almost done.
But
Say
do
it
you want
again?
us to do like the review, or like, because if I'm looking in the book here.
Hold on. You say you're looking in the book, or you're looking at my Math Lab?
So I'm looking at Math Lab.
All
So
right,
do I
so
just like
let me share
click
my
on
screen
it and then complete that?
Hold on, let me share my screen real quick. Make sure we're looking at the same thing. So this is my view, because I can unassign and stuff like that. So we got 1, 2, and 1, 3. That's what we did today. First 2 assignments, first 2 lectures, first 2 assignments. Now, if you want to move ahead, feel free. But the only thing you're responsible for are these assignments that are in my Math Lab. So I know you mentioned something like a review or something like that.
Yeah. I'm seeing it now though. For some reason, I didn't it wouldn't let me click on them at first, but if you click into it, it does come up with and you can click on question 1 and 2 now.
Yeah. So yeah, mine's like this. So this is what you guys should be seeing. This is how your view should see.
Yeah. It's letting me click in now. For some reason, when I clicked on assignments, it I don't know. Maybe I wasn't clicking right on the link enough, but
Okay. Also, I need to add your syllabus in there, but we pretty much talked about, and I've been sending you guys documents. I'll put that over here in this, in this tab, one of these tabs. I'll probably be right under course home, so I'll put that in there shortly. But yeah. All right. Anything else? Anybody else? So, like I said, we did 1, 2, and 1, 3 today, as far as lecture is concerned. If you want to be on task, or up to date as far as staying with me, you can knock out those 2 sections. No, if you don't get both of them done, there's no penalty. Just know that when I put that due date out there for chapter 1 and chapter 2, that's when you're going to want to have it done by. You want to have everything done by. But also, when I put that due date out there, I'm assuming that you've been doing work up to that point. So I'm not putting a due date. I'm not going to say, okay, all this stuff is due on Sunday or in a week, assuming that you still have 8 sections to do. It's supposed to be because you've already done stuff up to that point. Maybe you got 3 sections to do in order to be caught up. So keep that in mind when we get closer and closer to closing out chapter 2. We'll be looking to put a due date out there. All right. So anything else before we close? Everybody good? Everybody straight?
I just want to talk to you about the Math Lab and how to get on.
No, can't do it.
Has nothing to do with the.
Can't do it. No, I'm just messing with you.
Why?
All right, so I'm just messing with you. She was looking at me like, what? Yeah. So outside of her, to anybody else, everybody good? Everybody good? So I will see you guys in a week, man. This is gonna be tough. I'm gonna see you guys for a whole week. So next Thursday will be it. If you have any questions, feel free to communicate with me, because of course I'll be looking at this stuff throughout the week for my other classes anyway. So I'll be looking out for it. Outside of that, you guys have a great weekend. Be safe. Enjoy the holiday. I'll see you on Thursday. All right. So now, before you start talking, let me close off this recording. So I don't believe we need to record that, right?
Okay, now I don't have my laptop up there